Hi, everybody. Welcome back. Today we're going to be continuing our sensation and perception unit, and we're going to be talking about the sense of hearing. So, we're going to go through the anatomy of the ear and how the process of hearing works, and then you will get the chance to do a little Play Doh ear to narrate that process for yourself. So, let's get on to it. Audition is just the fancy name for the act of hearing. We talk about it as like auditory processing. And just like we talked about with visual stimuli, the energy comes in the form of waves. So with vision, we talked about light waves. And when it comes to hearing, we are processing these in sound waves, which kind of come in the form of vibrations eventually once they get into the ear. So we talked about the difference in wavelength and how that corresponds to difference in brightness and color or hue in visual stimuli. We're going to see that this also plays a role when it comes to processing auditory information. So, when it comes to the height of a wave, that determines its amplitude, which is how loud a sound is. Then, when it comes to the length of a wave, or like how spread or close together it is, that determines its frequency and pitch. And pitch is how high or low a tone is. So let's look at this in the picture here. So, right, amplitude we see is the height or kind of the vertical part of the wave. So if it has large or tall waves, it's great amplitude, then it's going to be really loud. If it has small amplitude and is very short, then it's going to be quiet like a librarian. Now, getting into, right, here we go. Getting into frequency. So wavelength, how spread apart or close together, horizontally we're talking, the waves are, is determining pitch of how high or low something is. So if it is low frequency, so spread out waves, then it's going to be kind of low pitched. If it is high frequency, meaning very spread together, then it's going to be high pitch, right? Um, there you go. You can think of your do, re, mi, fa, sol, la, ti, do in terms of pitch there, right? So you can see it here. Long wavelength, low pitch sounds, high or high frequency or spread out wavelength equals high pitch sounds. Okay, so just like I did with the eye, I've got our little overview chart of kind of the sequence of events that happens in terms of processing auditory information. So let's get onto it. We're going to break it down step by step. So first, and similar to what I did with the eye and hearing, I'm going to talk about things in terms of being waves, sound waves, but you're going to see my language will change once transduction occurs, and then we change it into neural impulse. Okay, so step one, we see there's kind of three parts of the ear. You've got the outer ear, the middle ear, and then the inner ear. So we're talking outer ear, which is the part of the ear you can see. That might you get pierced and all that good stuff. So the outer ear here is called the pinna. And the point of that, like why it looks like this, is to like kind of use it as a funnel. It's going to gather sound in to get it into the ear. So the pinna is just there to gather those sounds and acts as a little funnel. And it's going to then do its job as a funnel and send it into the auditory canal. So this kind of long tunnel. So auditory canal's function is just the long tunnel to kind of get it in to the middle ear. All right. So we're now in the ear. We've entered the auditory canal. So now they're going to the tympanic membrane or the eardrum. All right. So we see here, they've traveled down our tympanic or our ear canal, and now it's going to strike this guy here, which is the tympanic membrane or the eardrum. And this is what creates the vibrations, which actually continue to push the sound in and continue this process. So, easy way to remember this is like eardrum, obviously drum, right? That's going to create vibrations that you feel. Timpani is the big drum that you see in like symphonies and band, like actual like school bands and stuff. So you can remember it that way. So it's going to strike this and create those vibrations that get the ball rolling in terms of passing this sound on. So now that it's entered or it's struck the eardrum or tympanic membrane, it's got the vibrations, and that's going to push it forward through the middle ear. So there's 3 parts of the middle ear. We don't really need to know much about these parts individually. We just need to know that they consist of or make up the inner or the middle ear. So they are called the hammer, the anvil, and the stirrup. Now, these guys also have another name. You'll see, I don't know why, it's kind of silly. But the hammer is also called the malleus. The anvil is also called the incus. And the stirrup is also called the stapes. Again, in psychology, they like to give things like 20 different names. So you can also recognize it as that. So don't need to know much about these individually, but they make up the middle ear. So the vibrations or sound waves continue on. And once they get through here, they're going to get pushed through the middle ear and sent on to the cochlea. So the job of these little bones is just to kind of keep funneling that sound through, pushing it to the cochlea, which we're going to talk about is where the magic, aka transduction, happens. Okay. So now we're here. We're getting to the magic. Very exciting. So the vibrations now have gone through and were pushed through the middle ear, and they enter this little snail-like guy here, which is the cochlea. And the cochlea is a fluid-filled little snail-shaped object. So why I put Gary the snail with a hydro flask here is because I can remember it better this way, and that the cochlea, I picture Gary the snail holding a hydro flask, a little mnemonic device to remember that it's a fluid-filled little membrane. So the vibrations hit the cochlea, and I would put 5 stars in my notes for cochlea because this is where transduction occurs. So there's fluid in the cochlea. So because they're vibrations, it hits that and it's going to cause the fluid to now vibrate. And this creates ripples. And the little ripples in the fluid are going to cause these tiny little hair cells in your cochlea to now vibrate. So these little hair cells that are called the cilia are located on something called the basilar membrane. And this is where transduction occurs, is once these little hair cells of the cilia and the basilar membrane in the cochlea start moving and start kind of shifting, that is where transduction occurs. So it's the vibrating fluids creating the ripples, now causing these tiny hair cells of the cilia on the basilar membrane to begin that process of transduction and changing it from these little sound wave vibrations into neural impulses, the brain language that the brain can now interpret and understand and process these sounds. So just remember, cochlea equals transduction. Okay. So now we've made it through. So you're going to remember that in the eye, transduction occurs in the rods and cones in the retina. And as soon as transduction happens, it's kind of instantaneously like now exiting the eye, and that exits the eye through the optic nerve. Well, it's kind of the same thing here. So the cochlea is kind of the last part of the ear that it enters. And then after that, it's going to go through the auditory nerve, which is kind of the little exit door of the ear, and go up to the thalamus. So same thing as the optic nerve. Auditory nerve is kind of the exit or like connector between the ear and the brain, going up to the thalamus to be processed. So from here, you guys know the rest, right? So auditory nerve is going to carry it from the ear up to the thalamus. We know that it's going to take that pit stop in the thalamus because that's what everything except smell does. And it's going to get sorted out, organized, and then it's going to, of course, be sent to the auditory cortex and the temporal lobe for final processing. And there you have it. Last important thing to note, we talk about like color blindness with eyesight, so we're going to talk about hearing loss when it comes to hearing. So there's two forms of hearing loss to know. One is called sensory neural hearing loss, and has to do with nerve deafness. So if you remember, it's kind of the vibrations that take place in the cochlea that cause those ripples and the little cilia hair cells to move and start that transduction process. Well, when you have sensory neural hearing loss, that's when the cochlea's hair receptors have damage. So there's something wrong with the cochlea in that it's not allowing that process to happen. So this is where, if you heard of the term cochlear implant, I have a picture here. This is where a cochlear implant could be used to try and help fix this issue and restore someone's hearing loss. Now, conduction hearing loss is different, whereas sensory neural takes place in the cochlea. Conduction hearing loss happens when there's like damage or obstruction to structures in the outer or middle ear. So, like those three bones we talked about, hammer, anvil, stirrup in the middle ear, the ones that are in charge of transferring sound waves into the cochlea. So, this happens before it gets to the cochlea. This could be caused by anything in terms of like, oh, like it's straight up actually like damage, like something got, like bumped or broken, or even something like impacted earwax could cause this type of hearing loss. So that's all we got, and you'll be repeating this yourself with your Play-Doh ear.